The Space Shuttle, designed to provide NASA with a cost-effective reusable service into space. As it enters its 5th year of service, not a single astronaut has been lost, but on a cold January morning, this perfect record will be shattered and a shadow cast over every future launch. On the 28th of January 1986, at Cape Canaveral, Florida, USA, Space Shuttle Challenger is undergoing preparations for liftoff. It will be the 25th mission of the program and the 10th flight of this specific shuttle. Introduced in 1981, the Space Shuttle program was conceived as a successor to the large, costly single-use rockets previously employed. The reusable shuttles promise to lower the cost of launching crews into space, allowing for frequent and reliable transportation of people and cargo to low Earth orbit. Shuttle missions have been responsible for launching numerous satellites, probes, and even the Hubble Space Telescope. The shuttle itself is comprised of the orbiter vehicle, which is a delta-wing design measuring 56 meters in length, with 3 rocket engines in the rear which help power it during liftoff. It has a central payload bay for carrying its cargo, and located at the front is the cockpit, which typically houses a crew of 7 astronauts. Attached to the orbiter is a large orange external fuel tank filled with liquid fuel for the shuttle's main engines. Once its fuel is expended, it is jettisoned and breaks up in the atmosphere. This is the only part of the launch vehicle that is not reused. And attached to the external tank are a pair of solid rocket boosters, or SRBs for short. These provide the additional thrust needed to escape Earth's atmosphere. The SRBs provide the bulk of the thrust required during launch and contain solid fuel. They are composed of a nose cone, 4 main segments connected together at joints. In between these joints are O-rings which prevent the ignited fuel from escaping. Attached at the bottom are a rocket nozzle connected to a solid propellant motor, one for each booster. On landing, after re-entry, the orbiter vehicle will glide to the ground and land like a traditional aircraft. This shuttle, named Challenger, is the second oldest of the fleet and the so-called leader, being the most used at the time. This mission, named STS-51L, will see Challenger and its crew perform a routine satellite deployment, as well as observe Halley's Comet for 6 days. But that's not all, as this will also be the first Teacher in Space project flight, where one of thousands of applicants has been chosen to be the first civilian to fly on a space shuttle mission. It was introduced to increase public interest in NASA and spaceflight, as well as help inspire younger generations to pursue careers in mathematics and science. The teacher selected is Krista McAuliffe, and she will join the rest of the crew: Commander Francis Scobie, Pilot Michael Smith, Mission Specialist Ellison Onizuka, Mission Specialist Judith Resnick, Mission Specialist Ronald McNair, and Payload Specialist Gregory Jarvis. The morning of the 26th of January had seen record low temperatures for the area overnight, and the launch pad and shuttle are covered in ice. Despite being delayed for 2 hours to allow the ice to melt, this liftoff will be the coldest on record. Adding to this, a nearby flight had that morning reported a strong crosswind over the launch site. At 11:38 AM, Space Shuttle Challenger's engines ignite and the vehicle begins its climb towards space. Thousands of onlookers spectate the awesome sight, including many in schools across the US, where classrooms allow the students to watch the launch live on TV. Initially, while still in the thicker air closer to Earth, after initial liftoff, the throttle is rolled back to a lower setting of 65% due to the aerodynamic forces acting on the vehicle. If they go too fast at this stage, the stress will be too much to handle. When they reach the suitable altitude where the air is thinner, creating less drag on the shuttle, the go-ahead from control to go at throttle up will be issued. This means it's safe to increase throttle to the power required for the ship to achieve the velocity needed to escape Earth's gravity. Shortly before the command is given, Challenger is buffered by a crosswind, rocking the shuttle back and forth for a few seconds. It is noticeable, but nothing the ship's structure can't handle. The pilot comments to the commander, "Looks like we've got a lot of wind here today." At 11:39 and 8 seconds, Capcom gives the go-ahead. Challenger go at throttle up. Power is increased to the max and Challenger accelerates. 73 seconds after liftoff, without warning, the shuttle is entirely consumed by a fireball and the two boosters separate, flying off uncontrolled. Challenger and all 7 on board are lost. Debris begins to rain down, but luckily, as Challenger was over the ocean at the time of breakup, there are no injuries on the ground. There is some short-lived hope the crew may have survived somehow when a parachute is seen, but it is merely the nose cone from one of the boosters. An investigation is launched immediately afterward, and camera footage from the launch is scrutinised thoroughly. During launch, a plume of smoke can be seen coming from a joint in one of the SRBs. Investigators think a leak in the booster could have caused the explosion, but they are designed to prevent this from happening. Due to the temperature shifts that occur under operation, the metal the boosters are made from is expected to expand and contract with the heat. To prevent the burning fuel from escaping, between the joints a series of O-rings are in place to keep an airtight seal between the different sections of the boosters. But at low enough temperatures, the rubber the rings are made of becomes stiff and not as flexible as normal. Due to the freezing temperature on the day of this launch, the coldest ever, one of the O-rings didn't fully seal the gap and burning fuel was allowed to escape, explaining the smoke seen at launch. But what doesn't make sense is that this should in theory cause the SRB to explode instantly on the ground before lifting off, not over a minute into the mission. The footage shows smoke escaping, but it quickly stops, only later to reappear as a jet of flame which burns a hole into the external fuel tank, causing the explosion. To explain this, investigators come up with a theory. To make rocket fuel combustible enough to produce the amount of thrust required, aluminium is added. This added metal produces an additional waste product to the exhaust known as slag, essentially tiny fragments of burnt metal. It is thought this slag temporarily plugged the gap between the O-ring and the inside of the booster, but when Challenger is later rocked by turbulence, it is dislodged and exits through the gap, allowing a jet of burning solid fuel to exit, acting as a blowtorch, burning into the external tank, igniting the whole thing. On a previous flight, the next coldest on record, Discovery, one of Challenger's sister ships, experiences a similar fault and an O-ring is burnt almost all the way through, but just held out. That flight escaped the same fate by millimeters. This fault during cold weather was even known about by NASA and the manufacturers of the solid rocket boosters, Thiokol. In fact, Thiokol initially tried to cancel the launch due to concerns of this very thing happening, but their management, along with NASA's, overrode the concerns. The main man who tried to voice his doubts and postpone the launch until it was safe was Roger Boisjoly, a Thiokol engineer. Compensation is paid to the victims' families, but no individual from NASA or Thiokol management are held personally responsible or charged. A new orbiter named Endeavour is commissioned a year later in 1987 to replace Challenger. Flights are resumed after a redesign of the solid rocket boosters, and the shuttle fleet would fly safely for a number of years afterwards. But 17 years later, in 2003, the world will once again be reminded of the Challenger disaster when Space Shuttle Columbia breaks apart on its re-entry into Earth's atmosphere. If you enjoyed this mini documentary, give it a like for the time and effort it took me to make it, and if you don't want to miss future episodes, make sure to subscribe to the channel. Thank you so much for watching, and I'll see you next time.